Hi everyone. Today in this video I am going to solve some examples on homogeneous differential equations. So without wasting our time, let us move to the whiteboard. Homogeneous equations. A function f into bracket x comma y is said to be homogeneous of degree n in x and y if we express f into bracket x comma y is equal to x raised to n, x raised to n f sorry g into bracket y divided by x. So if we express the given equation in the form of g of y by x, where you can take the highest power of x outside, and if you express in the form of y divided by x, then you can say that the given function f of x comma y is homogeneous. Suppose one more, a differential equation of the form a differential equation of the form dy divided dx is equal to f into bracket x comma y divided by g into bracket x comma y, where f into bracket x comma y and g into bracket x comma y are homogeneous functions of the same degree in x and y is called a homogeneous differential equation of the first order. So please remember, a differential equation of the form dy by dx is equal to f of x comma y divided by g of x comma y, where if it has x and y has same degree, then you can say that the given differential equation is a homogeneous differential equation. Let us consider a homogeneous differential equation. Let us consider a homogeneous differential equation dy by dx is equal to f into bracket x comma y divided by g into bracket x comma y, and say this is equation number 1. Then in such cases you can take dy by dx. The same equation we can also write it as f of x comma y is nothing but there is a equation which contains x and y. In such cases, you can take the highest power of x outside. So let us say x raised to n is outside. Then the remaining term, then the function changes. That changed function we can write it as phi. And the remaining term is in the form of y divided by x. Similarly, in denominator also you can take x raised to n means highest power of x common, then the g function changes and let us take that is si. The remaining term is in the form of y divided by x, where so in this case you can take x raised to n means the highest power of x common, then f changes to phi, the function changes and the remaining term is in the form of y divided by x. Similarly in denominator, where x raised to n and x raised to n get cancels, at that time you will get dy divided by dx is equal to phi into bracket y divided by x divided by psi into bracket y divided by x. Now to solve this equation, I will write here, to solve this equation, put y by x is equal to p. You can take the substitution, this y divided by x is equal to p. So what you will get, that implies y is equal to p into x. Now if we differentiate with respect to x, what we get, differentiation of y with respect to x is dy by dx is equal to, now right hand side vx is a product function and you have to differentiate by using product formula. So first term v as it is, differentiation of this x with respect to x is 1, I will leave that term, plus second term x as it is and differentiation of v with respect to x is dv divided by dx. Now we have to substitute this value in equation number 2. So first I will show you the difference equation number 2. So let us say this is equation number 2 and here you can substitute the value for dy by dx as well as y by x. So first I will substitute the value for dy by dx. So this value dy by dx, we can substitute this value. So if you substitute, you will get that is phi plus x into dv divided by dx. This is the value for dy by dx and this is equal to, now you have to write down this right hand side value. If you write the right hand side value, what is right hand side value, that is phi into bracket, what you will get, y by x is nothing but v divided by psi into p. Now we have to separating the variables. Separating the variables, on separating the variables you will get the required solutions. So here I will write which can be solved by separating the variables. Means in this case, in this last equation here, so here you can separating the variables which contains, you can collect the terms containing x and dx on one side, v and dv on the other side, and then you can integrate. So which can be solved by separating the variables. So please remember, homogeneous differential equations can be solved by taking the substitution either y is equal to px, y is equal to px, or y by x is equal to v. Sometimes you can take y is equal to vx, and sometimes you can take y divided by x is equal to v. Both are one and the same. So differential equation, homogeneous differential equation can be solved by taking the substitution y is equal to vx. And homogeneous differential equation means homogeneous functions of the same degree in x and y. If x and y have the same degree, then such type of functions is called as the homogeneous functions, that is homogeneous differential equations. Now solving method. Just I will give the few steps how to solve a homogeneous differential equation. First one, from the given differential equation, find dy by dx. This is first step. Then second step, put y is equal to vx. Either you can take y by x is equal to v or y is equal to vx. If you differentiate with respect to x, what you will get? Dy by dx is equal to, by using product rule, p plus x into dv by dx. You have to substitute both the values in this value. Okay. Then third, separating the variables. Separating the variables means collect the terms containing x and dx on one side and v and dv on the other side. So you have to collect the terms containing x and dx on one side, v and dv on the other side. And the last step, on integrating, we will get the required solution. We will get the required solution. So please remember the method of solving the homogeneous differential equation. First, whatever may be the given differential equation, from that equation first find the value for dy by dx. This is first step. Second step, you can take y is equal to vx. Wherever you will have y, substitute the value for y is equal to vx. And then if y is equal to vx and if you differentiate with respect to x, then what we get? Dy by dx is equal to v plus x into dv by dx. You have to substitute the value for dy by dx also. Means substitute the value for dy by dx as well as the value of y. And then the given equation will convert from x, y to x and v. Then you can collect the terms containing x and dx on one side and y and dy, v and dv on the other side. Then on integrating, you will get the required solutions. Let us solve the examples. Let us take an example. Solve x square plus 2y square bracket complete dx minus xy into dy is equal to 0. So first we have to check whether the given differential equation is homogeneous or not. So homogeneous means if the degree of x and y are same, then you can say that It is a homogeneous equation. So from the first one, the degree of x is equal to 2, and here the degree of y is equal to 2, and in third one, here degree of x is 1 and degree of y is 1. 1 plus 1 is also equal to 2. Therefore, the given differential equation is a homogeneous of degree 2. Now first step. First find the value for dy by dx. So to find the value for dy by dx, I will write first this x square plus 2y square bracket complete dx. Transpose this second term to the right hand side. So that is equal to xy into dy. Now transpose this dx to the right hand side and this xy to the left hand side. So what you will get, I will write directly, that is dy divided by dx is equal to x square plus 2y square divided by xy. So this is the first step. We have to find the value for dy by dx. Now what is the second step? Second step, we have to put the value of y is equal to vx. Wherever you will have y, substitute the value for y is equal to vx. And if y is equal to vx, then what is differentiation? Differentiation is dy by dx is equal to v plus x into dv by dx. Right hand side you have to differentiate by using product rule. Now substitute both the values, the value of y and the value of dy by dx in the above equation. Here you have to substitute the value for dy by dx and substitute the value for y here as well as here. You have to substitute the value for y. Then what we get? If you substitute the value for dy by dx in the left hand side, first I will substitute the value for dy by dx. What is? That is v plus x into dv divided by dx is equal to. Now substitute the value of y. Here you can substitute value for y here and you can substitute value for y here. Y value is equal to what? Vx. If you substitute y is equal to vx, what you will get? The first x square as it is plus 2 into. Now we have y square. If y is equal to vx, then what about y square? Y square is equal to v square and x square divided by in denominator, first write x as it is. The remaining term is y. Substitute the value for this y. Y value is equal to vx. Y value is equal to vx. So this is equal to, that is v plus x into dv divided by dx. X square you can take common, then write down the remaining terms. The remaining terms are 1 plus 2 v square divided by this x into vx. This x into vx we can write it as vx square. Vx square. Now in numerator as well as in denominator, x square get cancels. Then v plus x into dv divided by dx is equal to 1 plus 2 v square divided by v remains. So this is the second step is over. Now the third step, you have to collect the term containing v and dv on one side, x and dx on the other side, means separating the variables. On separating the variables, we get. Now how to separate the variables? To separate the variables, first transpose this v. Transpose this v to the right hand side. 1 plus this 2v square and minus v square. 2v square minus v square is equal to plus v square divided by v. Left hand side we have x into dv by dx. Now collect the term containing x and dx on one side, v and dv on the other side, means transpose this term to the left hand side. If you transpose this term to the left hand side, we get v divided by 1 plus v square into dv, and then transpose this x divided by dx, this x divided by this dx to the right hand side. Then what we get, that is equal to dx divided by x. So this is nothing but the variables are separable. V and dv on left hand side, dx, and that is 1 by x, and dx is on the right hand side. Now the next step is to integrate. Now to integrate, first we have to check the differentiation of denominator. Here denominator is 1 plus v square. Then what is its differentiation? Its differentiation is 2v. So in numerator 2 is absent. So I will make adjustment. I will write here 2 and divided by, I will write here 2. So this is an adjustment. So therefore multiply and divided by 2. If you multiply and divide it by 2, what we get, I will write in the next step. That is 1 divided by 2 into bracket 2v divided by 1 plus v square, bracket complete, into dv. This is an adjustment. Multiply and divided by 2 only. Dx divided by x, that is the right hand side term. So next I will write, on integrating we get, on integrating we get. What is integration of 1 plus v square? First I will write this 1 by 2 as it is. 1 by 2 as it is. Into bracket. Now what is the differentiation of this denominator? Denominator is 1 plus v square. So its differentiation is equal to 2v, and which is the numerator term. So therefore if suppose 1 by x and its integration, what is differentiation of this x? Differentiation of x is 1. So we can write it as logarithm of denominator, that is log x. Similarly here, differentiation of 1 plus v square is 2v, which is numerator term. So we can write it as logarithm of 1 plus v square is equal to, what is integration of this right hand side term? In here also 1 by x, differentiation of x is dx. So directly we can write it as integration of 1 by x into dx is log x. Now both the terms are in logarithm. So now I will take integrating constant log c. Okay. Now transpose this 2 to the right hand side. If you transpose this 2 to the right hand side, what you will get, that is logarithm of 1 plus v square is equal to 2 log x plus 2 log c. Then this is logarithm of 1 plus v square is equal to, now by using property this 2 log x we can write it as log x square, log x square. Similarly, the next term we can write it as logarithm of c square. Now, by using the property of logarithm, for the right hand side term, log u plus log v is equal to log u into v, that is logarithm of x square into c square. Left hand side we have logarithm of 1 plus v square. Now both the sides, this log and log get cancels. Now write down the remaining terms. The remaining terms are 1 plus v square is equal to x square into c square. Now substitute the value of the value of v. We have taken the value of v is equal to y by x, because y is equal to vx means v is equal to y by x, and if we substitute you will get that is 1 plus y square divided by x square. V square is nothing but y square divided by x square, and this is x square into c square. Now if you take LCM in left hand side, LCM is x square, and by using cross product this x square into 1 is equal to x square plus y square is equal to x square c square. Transpose this x square to the right hand side, you will get x square plus y square is equal to x raised to 4 into c square, and this is the required solution.